Welcome to this discussion on MultiCAD design reuse, as it is supported by the Teamcenter Creo integration. Let's begin by defining what is meant by MultiCAD design reuse. In general, it means designing your Creo assembly around, and in some cases against, existing design data authored in other CAD software. It can be subdivided into three modes or categories. Direct reuse means the non-native models are never converted to Creo models, they are just used as is, in the Creo session. Direct reuse is possible for SolidWorks, Inventor, Solid Edge, and depending upon configuration choices, CATIA. Indirect reuse means first converting the non-native files into a neutral format, such as JT or STEP, then importing them into Creo. Finally, hybrid reuse involves directly reusing the non-native models, but only at the part level. The non-native assemblies are constructed on the fly, by the Teamcenter Creo integration, as they are opened. This category applies to NX, and in some cases, CATIA. In the demonstration, we will see examples of all three types of MultiCAD reuse, within a top-level Creo assembly. Direct reuse is possible anytime Creo will read the non-native format through its Unite technology, which was introduced in Creo 3. A key benefit of direct reuse is that the Creo designer can use the non-native models as if they were native, he can establish parametric constraints to them, and as the non-native designs are changed in their authoring tools, and saved to Teamcenter, the Creo design will adapt. Note this does require an additional per CAD license from PTC. An important consideration, and potential drawback, of direct reuse is that it requires careful management of the version dependencies between Creo and other MCAD software. The Creo version must be new enough to open files from the other CAD tools. Indirect reuse is the more traditional data exchange technique, in which a neutral file is exported from the CAD session, then imported into Creo. Common examples are STEP and JT. In the managed Teamcenter environment, it has several limitations, as noted here. The Teamcenter Creo integration has supported JT-based reuse for a long time, and it does not require any special configuration settings. Creo itself does, however, require an additional PTC license, to open JT files. Unlike direct reuse, indirect reuse cannot provide parametric associativity. Any CAD-level constraints attached to non-native models will be lost the next time the Creo assembly is opened. On the plus side, version compatibility is usually not an issue with indirect reuse, precisely because the exchange format is neutral to both the authoring and the reusing CAD software. The third and final reuse category is hybrid. It is not yet supported by the Teamcenter Creo integration, but can be evaluated by adding undocumented settings, which will be explained here. It's based on the long-standing technique used by the integration for JT-based assembly reuse, which is to download the part JT files, then build the non-native assemblies on the fly, as the JTs are being imported into Creo. In the hybrid case, the non-native CAD parts are downloaded, and their assemblies are dynamically built by the integration, using the positional information from the Teamcenter BOM view revisions. The goal is to retain some degree of associativity, as long as constraints are made against only the parts, and not the assemblies. This technique is appropriate in cases where the non-native assemblies cannot be opened from Teamcenter without the involvement of their Teamcenter integrations. This is always the case with NX. Several rules are observed by the Teamcenter Creo integration, when working with non-native design data. First, if a native Creo model is found, it will always be used. Any other MCAD file, even if configured for reuse, will be ignored. Non-native models that are opened or inserted from Teamcenter cannot be saved back to Teamcenter as Creo models. This preserves their identity and avoids duplication of designs under different CAD formats. Finally, nested reuse cannot be supported. Non-native assemblies of any depth may be inserted into Creo parent assemblies, but they themselves must not contain any non-native children. Several configuration settings serve to tell the Creo integration which non-native formats may be used as components. Two sets of preferences in IPEM.properties specify the types of datasets, and the named references within those datasets, that are eligible for reuse. Please note that all type names must appear in the IPEM.properties file exactly as they are defined in the appropriate BMID template, including case. For each dataset type mentioned in the IPEM.properties file, up to 3 entries are required in the BOM map section of the IPEM.xml file. These entries specify which non-native types may be used by Creo assemblies, as well as which non-native part datasets may be used by non-native assemblies. Here we see a SolidWorks example. Unlike the IPEM.properties preferences, all dataset type names used in the BOM map must be entirely uppercase. Now let's look at some examples of direct, indirect, and hybrid MultiCAD design reuse. First, we'll directly insert a SolidWorks and an Inventor subassembly into a Creo design. Here we see the necessary settings in both the IPEM.properties and the IPEM.xml files. Preferences in both IPEM.properties and IPEM.xml control which datasets and which named references may be reused, and which parts may be used by which assemblies. Now let's create a new Creo assembly, so that we can add both SolidWorks and Inventor designs to it. Using standard integration functionality, the SolidWorks assembly is found in Teamcenter, and inserted into the Creo design. Along the way we can clearly see that the model being inserted was not authored in Creo, and if desired, we can see its assembly structure. Creo is opening, not importing, the SolidWorks models. The next step is to find and insert a native Creo subassembly, and to position it with parametric constraints to the SolidWorks subassembly. This is only useful for directly reused models. Similar constraints can be established to indirectly imported models, but they will be lost when the Creo design is reopened. Now let's find and insert an Inventor subassembly. Here I'm using Creo 6.0.4.0 and Inventor 2019. According to the PTC compatibility matrix, these versions are compatible. However, our results indicate otherwise. Although my Creo version can open Inventor 2019 files in standalone mode, the insert fails when the integration calls the PTC API. This bug has been reported to PTC. What can be done? I still want to reuse the Inventor design in my Creo assembly. We can revert to indirect JT-based reuse simply by removing all references to Inventor datasets from the IPEM.properties and IPEM.xml files. Configuring Inventor for hybrid reuse is not an option, because Creo will not even open the Inventor part files via the API. Now when we insert the Inventor assembly, we see that the integration has chosen its JT files, instead of its native Inventor files. It will use these JT files to build the Inventor assembly on the fly, within Creo. And the Inventor subassembly can be inserted into the Creo design. Constraints can be made, but they will be lost when the Creo design is reopened. To summarize, at this point we have a top-level Creo assembly directly reusing a SolidWorks subassembly and indirectly reusing an Inventor subassembly. When you expand the Inventor subassembly, you can see that all of its JT parts have been converted to native Creo models. Now let's save our work back to Teamcenter, before continuing. The integration will not allow you to save the dynamically constructed Inventor assembly, or its components, to Teamcenter. Doing so would create duplicate Creo datasets under the Inventor item revisions. Let's see what happens when the SolidWorks design is changed, and then saved to Teamcenter, in a way that affects the positioning of the Creo subassembly. We will also modify the structure of the indirectly reused Inventor subassembly. Here I've extended the tube into which the Creo subassembly was inserted, changing the position of the surface to which the Creo subassembly is offset. For the Inventor subassembly, I will simply delete the two grease fittings, changing its bill of materials. When the top-level assembly is reopened in Creo, the changes to both the SolidWorks and the Inventor subassemblies are seen, but the native Creo subassembly is initially out of position with respect to the SolidWorks design. This is because I don't have the additional PTC license, collaboration extension for SolidWorks, to enable the update to happen automatically. The update can be forced by editing the definition of the SolidWorks design. We'll finish by enabling indirect reuse of a part step file, and hybrid reuse of an NX design. The ipem.properties file is updated with data set and named reference types for step and NX. The ipem.xml file's BOM map is extended to include the step and NX data set types. Notice there are fewer entries for these types, because a step file managed in Teamcenter, even if it's an assembly, cannot have a bill of materials, and b while a UG master dataset may represent an assembly, and have a bill of materials, it cannot be opened without the involvement of the NX integration, and so the Creo integration must build the assembly itself, using the NX part files. This is the effect of the special tag that reads assembly equals ignore. This will become a documented feature in the integration's 13.0.1 release. This landing gear assembly needs an axle upon which to mount the nose wheel assembly. The axle is available in Teamcenter as a step file. It might have been authored in any mechanical design software. Unlike the other formats, the user must locate the downloaded file, and must also take care to make the right choice, when asked whether to import it as a part or an assembly. In this case, the correct choice is part. Now we can complete our Creo design by adding the nose wheel assembly from NX. Remember that NX is configured for hybrid reuse. The Creo integration will download the NX part files, and will build the assembly using positional information from the NX design's bill of materials. With this technique, native Creo models can be constrained to the NX part files, but not to the dynamically constructed Creo assembly that represents the NX assembly. When we save the completed Creo design to Teamcenter, it's apparent that the Creo integration is aware of what has been reused from other authoring tools, and what is native to Creo. The red stop icons mean these models cannot be saved. From top to bottom, they are the NX wheel assembly, the JT-based Inventor fastener, the step axle part, the native Creo subassembly, which can be saved, and the SolidWorks upper support. We hope you have enjoyed and learned from this overview of the MultiCAD mechanical design reuse support provided by the Teamcenter Creo integration. As you have seen, there are several different options for reuse of non-native design data in Creo, under Teamcenter management.